Welcome to the DIY Honda Garage channel. The DTC P050D indicates a cold start idle speed problem in the Honda CRV models from 2017 to 2022. This diagnostic trouble code affects the Powertrain Control Module, PCM, and the engine's idle behavior during cold starts. It is crucial for the PCM to receive accurate data from several sensors, including the engine coolant temperature, ECT sensor, and the mass airflow, MAF sensor, to maintain optimal idle speed. When this DTC is present, it can cause irregularities in the engine's performance, leading to stalling or rough idling, particularly during cold starts. To effectively address the issue, a systematic troubleshooting approach should be followed based on diagnostic steps, ensuring that all potential causes are investigated. In this guide, we will explore the specific symptoms, possible causes, and troubleshooting steps to accurately identify and resolve the issue related to DTC P050D. The DTC P050D refers to a cold start idle speed problem. The primary components affected include the Powertrain Control Module, PCM, which oversees the vehicle's engine management, and the engine coolant temperature, ECT sensor, which informs the PCM about the engine temperature. Additionally, the mass airflow, MAF sensor, plays a role in measuring the amount of air entering the engine, which is crucial for proper fuel-air mixture. These components are located in the engine compartment. The PCM is usually secured in a designated housing, while the ECT sensor is typically positioned near the thermostat housing. When the engine is cold, the PCM adjusts the idle speed based on readings from the ECT and MAF sensors, and any malfunction can disrupt this delicate balance, leading to the P050D code being triggered. Several possible causes can lead to the occurrence of DTC P050D. One issue may be a faulty intake air duct, which might have a poor connection or blockage preventing adequate airflow. If the air path is obstructed, it can affect the engine's ability to achieve the correct idle speed. Another potential cause is a damaged air cleaner housing, which can also restrict airflow if it's not sealing properly. Additionally, if the air cleaner element is dirty, it will further impede airflow, causing the engine to run inefficiently during cold starts. Addressing these potential causes is the first step in resolving the idle speed issue noted by the DTC. When DTC P050D is present, there are several symptoms that a driver might notice. The most common symptom is erratic engine idle behavior, particularly noticeable when starting the vehicle in cold conditions. This erratic behavior may lead to stalling, especially if the engine fails to maintain the proper idle speed. Additionally, an engine affected by DTC P050D may result in increased fuel consumption as the vehicle's engine management system struggles to find an optimal balance for fuel-air mixture. These symptoms not only impact the driving experience, but can also raise concerns regarding the vehicle's overall efficiency and performance. The initial step in troubleshooting DTC P050D involves turning the vehicle to the on mode, activating the ignition without starting the engine. This step is crucial for allowing the Honda Diagnostic System, HDS, to perform a status check on the vehicle's onboard diagnostic system. During this phase, it is essential to check for any pending or confirmed DTCs present alongside P050D. If other DTCs are discovered, the appropriate troubleshooting steps for those codes should be followed first before returning to address P050D. If no other DTCs are confirmed, the process proceeds to the intake air duct inspection. In Step 2 of the troubleshooting guide, a visual inspection of the intake air duct is conducted. This component is vital because it directs air into the engine, and any obstruction or poor connection can severely impact engine performance. While performing this check, Look for any blockages or disconnections that may have occurred. If the intake air duct is found to be damaged or incorrectly connected, it should either be reconnected, repaired, or replaced if necessary. Successful completion of this step ensures that the air intake path is functioning correctly, allowing the vehicle to move to the next diagnostic phase. The third troubleshooting step involves inspecting the air cleaner housing for any signs of poor connections or blockages. This housing encloses the air filter and allows ambient air to flow into the engine while filtering out debris. If the housing is not properly secured or shows signs of damage, it may cause inadequate airflow, which could trigger DTC P050. Inspect the housing carefully for any breaks or disconnections. If any issues are found, the air cleaner housing must be repaired or replaced to ensure optimal air intake and engine performance before proceeding to the next step of checking the air cleaner element. In Step 4, the air cleaner element must be visually inspected for any dirt or debris that could be hindering airflow. The air cleaner plays a crucial role as it filters out contaminants before air enters the engine. If the element becomes blocked with dirt, it can significantly impair the engine's ability to draw in fresh air, directly impacting performance and possibly contributing to the DTC P050D issue. If the air cleaner element is found to be excessively dirty, it should be replaced to restore efficient airflow. If it appears clean, the troubleshooting process will continue to further verify the problem. In the fifth troubleshooting step, allow the engine to cool down to 122 degrees Fahrenheit, 50 degrees Celsius or below, which is important for accurate evaluation of the DTC P050. After the engine has cooled, use the HDS to clear the existing DTCs. Following this, the engine should then be started and allowed to idle for at least 10 seconds. Monitoring the onboard diagnostic status during this time is crucial to determine if DTC P050 reappears. If the HDS indicates that the DTC has failed again, then the failure has indeed duplicated, and further steps will be needed to diagnose underlying issues. The sixth step revolves around evaluating the performance of the mass airflow sensor. To conduct this check, start the engine and maintain an engine speed of 3,000 revolutions per minute RPM in either park or neutral until the radiator fan activates. While performing this test, it is important to hold the engine speed at 2,500 RPM for 30 seconds, and then check the MAF sensor parameters using the HDS. Specifically, assess if the current values match the established malfunction thresholds. If the MAF sensor readings fall within the designated limits, it can be deemed functional, leading to the next step in the troubleshooting process. Conversely, if the readings do not match, the MAF sensor or the intake air temperature (IAT) sensor should be replaced. Step 7 focuses on checking the readings from the intake air temperature (IAT) sensor. Start by turning the vehicle to the off mode to allow the engine to cool down to the ambient temperature. Once cooled, note the ambient temperature before turning the vehicle to the on position again. Utilize the Honda diagnostic system to quickly check the IAT sensor's voltage reading. It's essential to compare this value to the recorded ambient temperature. Should the IAT sensor reading deviate by 5.4 degrees Fahrenheit, 3 degrees Celsius, or more, there is an indication of sensor malfunction, necessitating a replacement of the MAF or IAT sensor. If the readings are in alignment, further inspection of the throttle bore will be required to check for any dirt, carbon buildup, or damage. After completing all troubleshooting steps and any required repairs, it is vital to conduct a final verification to ensure that the vehicle operates correctly. This involves confirming that the engine runs smoothly without stalling or exhibiting erratic idle behavior during cold starts. Additionally, it is essential to check for any reoccurrence of DTC P050D within the Honda Diagnostic System HDS. Ensuring the idle speed is stable during various operating conditions is also a crucial part of this verification process. If all checks are satisfactory, it indicates a successful resolution of the idle speed problem. To prevent the recurrence of code P050D and maintain optimal performance, regular preventive maintenance is essential. It is advisable to frequently check and replace air filters as necessary, as a clean filter is crucial for proper airflow into the engine. Additionally, inspecting intake hoses and connections for any signs of wear or damage can help in ensuring an unobstructed airflow. Performing periodic checks and diagnostics with the HDS can also keep the vehicle in prime condition, catching any potential issues early before they evolve into DTC-related problems. Such proactive measures not only enhance performance, but also prolong the lifespan of the vehicle. In conclusion, addressing DTC P050D requires a thorough understanding of its symptoms, potential causes, and the prescribed troubleshooting steps. This code indicates that there is a cold start idle speed problem, which can lead to further performance issues if not resolved. The troubleshooting process outlined provides a structured approach to accurately diagnosing and fixing the issue, emphasizing the importance of checking multiple components, such as the intake air duct, air cleaner, MAF sensor, and IAT sensor. Performing regular maintenance checks is crucial for preventing such issues in the future. By adhering to these guidelines, vehicle owners can maintain optimal performance and longevity of their Honda CRV models from 2017 to 2022. Please like and subscribe to the channel. See you next time.